Hello everyone, this is Miss Ui here. Since so many of you were absent today, so I'm going to go over 7C, which is combinations of transformations. So let's look at what we have learned so far. So far we have covered translations, dilations, and reflections. All right, what does translation k units to the positive directions of y-axis means? So in terms of coordinate, this is what actually happened when you say translation in the positive direction of y-axis. So what happened is that you move k units up. So y coordinate now become y plus k. So in terms of functions, how does it look like? Y equal to fx plus k. This is the transform equations, or this is the image after being translated k units to the positive direction of y-axis. How about translations k units to the negative directions of the y-axis? What will happen now is that the y coordinate moved down by k units. X stay the same, so you move the point by k units in the negative directions of the y-axis, or k units down. So in terms of functions, we write fx minus k. How about translation of h unit to the positive direction of the x-axis? In other words, now we're going to add h unit to the x coordinates. So it's moving h unit to the right. So remember, x dash is equal to x plus h. Let's rearrange and make x a subject, x equal to x dash minus h. So remember, our old equation was y untransformed equations, which is the original is y equal to fx. Replace this ox with the new x, which is x in terms of dash, which is x dash minus h, and that's how we got that x minus h. So that tells me that h unit in the positive directions of x-axis. So translation of h unit in the negative directions of the x-axis, what will happen now is the x coordinate become x minus h. So that's h unit in the negative direction of the x-axis. So we're going to write x dash is equal to x minus h, x equal to x dash plus h. So you replace that ox by x plus h. That tells me that h unit in the negative directions of x-axis. What about dilations? What does dilation factor A from the x-axis mean? Dilations from the x-axis mean you're stretching from the x-axis, the coordinate from the x-axis. So what will happen is that now the y coordinate is going to change. So you're going to multiply. Let's erase this first. Going to multiply the y coordinate by a. So that's the dilation factor A from the x-axis. So in terms of functions, how does it look like? So remember, x dash equal to x, y dash is ay. Rearrange to make y as a subject, which give you y dash over a. So therefore, replace that oy with y dash on a, replace this ox is x dash. So our equation is a f x dash. And that's how we got this a here. That would tell you there's a dilation factor a from the x-axis. Okay. Next, dilation factor a from the y-axis. Dilation factor from the y-axis, you're stretching from the y-axis. What will happen is that that is going to affect the x coordinates. So in terms of coordinate mapping, xy has mapped to ay. So what does dilation factor a from the y-axis means? You multiply the x coordinate by a. All right, so x dash is equal to ax. Rearrange to make x as a subject or x in terms of dash, which is x dash on a. And that's how you replace that ox by x on a. That would tell you dilation factor a from the y-axis. Now, if you have ax, that tells you dilation factor 1 on a from the y-axis. That is the same as writing this. X over 1 on A is AX, the dilation factor 1 on A from the y-axis. And lastly, we want to talk about reflections. Reflection can be in the x-axis, can be in the y-axis. Reflection in the x-axis will change the y-coordinate. You're reflected in the x-axis. X is like a mirror, so y, positive y will become negative y. So therefore, y dash is equal to negative y is negative y dash. So sub that into that OY become new y in terms of dash, and fx stay the same, rearrange to make y dash a subject. So that's how we got this negative. That tells you reflection in the x-axis. And reflection in the y-axis, how does the function looks like? In terms of coordinates, that x become minus x, but in terms of functions, y equal to f of negative x, reflection in the y-axis. So this is what we have covered so far. And today let's move on to combinations of transformations. So let's look at the first example. A dilation factor 2 from the x-axis followed by a reflections in the x-axis. So let's look at the coordinate in terms of coordinate mapping. xy has mapped to x2y. That's a dilation factor 2 from the x-axis. That means that you multiply the y coordinate by 2, dilation from factor 2 from the x-axis, followed by a reflection in the x-axis. Reflection in the x-axis affect the y coordinates. So 2y become negative 2y. Let's look at the second example. A dilation factor 2 from the x-axis followed by a translation 2 units in the positive direction of the x-axis and 3 units in the negative directions of, I believe, the y-axis. So something missing there. So dilation factor 2 from the x-axis. What does that mean? It changed your which coordinate? Y coordinate. Dilated from the x-axis. You're stretching from the x-axis by what factor? 2. So you multiply this y by 2. So it becomes 2y. And then you move 2 units to the right. So that x, you add 2. And then you take away 3 because you move 3 units down. So 2y minus 3. So xy has maps to x plus 2 comma 2y minus 3. Next, find the equations of the image of y equal to square root x under a dilation factor 2 from the x-axis followed by a reflection in the x-axis. So let's start with the coordinate mapping. So xy has mapped to x2y, that's a dilation factor 2 from the x-axis, followed by reflections in the x-axis. It's a negative here. So now what we're going to do is we are going to write the image of x, which is x dash. So let's write x dash, which is x. The image of y, let's call it y dash. So the image of y, that whole thing is the image of y. All right. So y dash is equal to negative 2y. So rearrange to make y as a subject. So we can say that y is equal to negative a half y dash. Our next step is you're going to replace this x in terms of dash, y in terms of dash into our original equations. So in order for us to find the new equation or transform equations, you're going to replace old by new. So that's my original equation, y equal to square x. So that y is going to replace by this y. So it's negative half y dash. Square root x dash. X dash is the same as x. All right, there's no nothing happened to the x coordinate. Then rearrange to make y dash as a subject. All right. So y dash is equal to negative 2 square root x dash. So the image of y equal to square root x under that transformation, so the equation of the image is equal to, or is, y equal to negative 2 square root x. We drop the dash, that dash has replaced by the word image. All right, let's look at example. Let's look at part B. Find the equations of the image of y equal to square root x under a dilation of factor 2 from the x-axis, followed by a translation of 2 units in the positive direction of the x-axis and 3 units in the negative directions of the y-axis. All right, let's see what happened in terms of coordinate, right? So xy, there's a dilation factor 2 from the x-axis. You multiply the y coordinate by 2. There's a dilation factor 2 from the x-axis. Change your y coordinate. And then followed by translation 2 units in the positive directions. So you move 2 units to the right. So you add this x coordinate by 2, so become x plus 2. And then you move 3 down, so that 2y become 2y minus 3. So our image of x, which is x dash, is x plus 2. So let's write x dash is equal to x plus 2. The image of y, let's call it y dash, which is 2y minus 3. Now, rearrange to make x as a subject. Let's write x in terms of dash. X equal to x dash minus 2. And then make y as a subject, another y. Write y in terms of dash, which is 2y equal to y dash plus 3. Y equal to y dash plus 3 divided by 2. And that's what we have written here. Y equal to y dash plus 3 divided by 2. Right, what's next? You say, yeah, we need to replace that old equations by now new. So replace the old y with the new y, which is y in terms of dash. So y equal to square x is the old. Replace that with y dash plus 3 on 2. Replace this x by x dash minus 2. All right, slowly rearrange, make y dash as a subject. So y dash plus 3 equal to 2. Bring 2 over to that side and take away 3. So therefore, the equations of the image is y equal to 2 square x minus 2 minus 3. Again, we drop dash and we replace by the word image. The equation of image is that. Right. Next one. Find a sequence of transformations which take the graph y of y equal to x squared to the graph of y equal to 2x minus 2 squared plus 3. Now, before that, you were given a sequence of transformation, and then you were asked to find the image. In these questions, you are given the equation of the image. You are told that this has mapped to that. You are now, what the question wants us to find is what transformation have taken place. How does this become that? What kind of transformation? So we're going to use, the first method we're going to use is called coordinate mapping in reverse. And what that means is that we're going to do like backtracking. Remember our last step was when it's image, we always end with y dash. So now let's write down, this is an image. Let's put a dash back. So let's put a y dash back and x dash back. So let's begin from our last step. And we say that y equal to x squared has mapped to these equations. So that's the image. So let's put a dash back, y dash equal to 2, x dash minus 2 squared plus 3. Now, what we're going to do next is that we are going to place these transform equations back into that original form, into the form of the basic or in the form of untransformed functions. So we are going to slowly unpack this. So y dash, going to put back to the other side. So y dash minus 3 divided by 2. So y dash minus 3 times 2. So the opposite of times 2, you divide by 2. Now look at this. This is now in this form. That's y was replaced by y dash minus 3 on 2 before. And remember the ox was replaced in terms of dash before. So now we can map this. This is now in that form, all right, in the untransformed function form. So we can say now y is equal to this. Let the left-hand side equate to the left-hand side. So y is equal to y dash minus 3 on 2. And the one that's inside the bracket, which is x dash minus 2, is equal to the x. All right? And next is we want to solve for x dash and y dash. In other words, we make y dash and x dash as subjects. Solve for x dash and y dash. So that one will become y dash minus 3 is equal to 2y. Y dash is equal to 2y plus 3. And let's make solve for x dash. X dash is equal to x plus 2. All right? So therefore, we say that xy has now mapped to the image of x is x dash, which is x plus 2. The image of y, which is our y dash, is 2y plus 3. Now we are ready to state the transformations. So there is a transformation of dilations factor 2 from the x-axis because there's a change in the y coordinate. So there's a dilation factor 2 from the x-axis, followed by a translations of 2 units in the positive direction of the x-axis and 3 units in the positive directions of the y-axis. So the transformation is a dilation factor 2 from the x-axis, followed by a dilation of 2 units in the positive directions of the x-axis and 3 units in the positive direction of the y-axis, or you can simply just say followed by a translation of 2 units to the right and 3 units up. We'll talk about DRT. So method number 2, which is what I call the DRT. Before we can use this DRT, what does DRT stand for? It means dilations, reflections, translations, which is affectionately known as Dr. T. Before we can use this Dr. T method, we need to rearrange our equations in this form. This is called the standard function form. It starts with dilations and then it ends with translations. And then once you write in this form, you can now read from left to right. And as I say here, this gives immediate access to a valid sequence of transformation from the more basic rule of y equal to fx. This a and b are basically just numbers. They are just real numbers except 0. And h and k are also real numbers. Okay, so what does this A stand for? This A, as we know, it is dilation factor of A from the x-axis. So remember, I start the lesson by recap what we have done in the last lesson. We say if that's A in front, we say there's a dilation factor A from the x-axis. What if this A is a negative value? So not only are you going to say dilation factor A from the x-axis, you will also say a reflection followed by reflections in the x-axis, provided if A is negative. Now that B tells me dilation factor 1 on B from the y-axis. Remember, if I give you x over B, we say dilation factor B from the y-axis. So if we have dilation Bx, we say dilation factor 1 on B from the y-axis. Okay, the number that is next to x tells me the dilation factor from the y-axis. X has been replaced by x minus h. It tells me there's a translations of h units in the positive directions of the x-axis if this h is a positive number. All right, or you can say h unit to the right. Okay, and that k tells me up and down. K units up if k is positive, or you can k units in the positive direction of the y-axis. So the sequence is, as I mentioned before, affectionately known as Dr. T, all right, which indicates the order of transformation, dilations, reflections, and lastly, translation. The order is important. In this, when you write this in this standard function form, we always read from left to right. These dilations and reflections, however, you can actually interchange. In other words, there's nothing wrong to say reflection first, then dilations, but the lastly, always translations. So the only important positioning in this sequence are the translation, which must always come last. Right, let's look at the next example. Determining transformation. Find a sequence of transformations which take the graph of y equal to x squared to the graph of y equal to half 1/3 x minus 3 squared minus 4. Now, I'm going to briefly talk about the DRT method, then I'm going to talk about coordinate mapping way. So if I were to use the DRT method, I got to firstly transform that into the standard function form. So what does standard function form means? I write half, 1/3. Now, remember this is a standard function form, a, f, b, bracket, x minus h plus k. Now, if you don't put this in the bracket, in that bracket, you're going to say it wrongly. You're going to think like there's a translation 3 units to the right, which is wrong. So I put 1/3 out. It's actually x minus 9. Is that right? Okay, 1/3 times 9 minus 9 is minus 3. Okay, then square, okay, the whole lot square, minus 4. So if you are using DRT where you just read from left to right, this half tells me that there's a dilation factor half from the x-axis. This 1/3 tells me, which is inside the bracket, it tells me dilation factor 3. Remember, it's reciprocal of that 1/3. So dilation factor 3 from the y-axis, and there's a followed by a translation of 9 units to the right, or 9 units in the positive direction of the x-axis, and followed by a translation of 4 units down, or 4 units in the negative direction of the y-axis. So it's quite easy. We just read from left to right. Now let's do the coordinate mapping way. And coordinate mapping, I like to do that because it is a very intuitive, and also it is a very important method that you will find out why maybe to the end of this chapter 7. All right, so let's go through the coordinate mapping. So coordinate mapping, we're going to do what coordinate mapping in reverse, this method. And like the example before, the image, the one that say this is the image, we're going to put a dash back. So y equal to x squared has mapped to that equations. So let's put a dash back because that's image. All right. Then you are going to rearrange that transform equations into the format, into the untransformed form, into this format like y equal to something squared. So I'm going to rearrange that. So let's do slowly unpack. So place the complex or transform functions in the form of the basic functions. Okay, so let's clean up this. So I'm going to have y dash minus 4, so become plus 4, and times half to the other side, times 2, Okay, together half I times 2. And that's what we have. This is already in the form of y, that's OY, has been replaced by 2 bracket y dash plus 4, and that OX has been replaced by that. So let's match this. Y, the left-hand side, equal to this left-hand side. So y is equal to 2 bracket y dash plus 4. The right-hand side, which is the value, the number inside the bracket, which is 1/3 x dash minus 3, is equal to that x. Okay, rearrange to make y dash and x dash as a subject, or rather we solve for y dash and x dash. So I'm going to say y over 2 is equal to y dash plus 4. So y dash is equal to y over 2 minus 4. How about this one? So I'm going to have 1/3 x dash is equal to x plus 3. X dash is equal to 3x plus 9. So solve for x dash, y dash, like I said before, and that's what we got. And this is what happened. X, y maps to the image of x is 3x plus 9. The image of y is half y minus 4. Now we are ready to state the sequence of transformations. So we say that the transformation is a dilation of factor half from the x-axis. Dilation factor half from the x-axis, change the y coordinates, and then a dilation factor 3 from the y-axis. Dilation factor 3 from the y-axis, followed by a translations of 9 units in the positive directions of the x-axis and 4 units in the negative directions of the y-axis. All right, or you can say 9 units to the right, 4 units down. So notice that we say dilation first, and then we say translations. Dilations followed by translation. Clean up all the mess so you have a neat PowerPoint. All right. Okay, so that's all for today. Your homework is exercise 7C. I shall see you next lesson. Bye for now.